Hello dear students. In the previous class we were discussing about the valence bond theory, hybridization, then how do we draw the overlapping diagram for CH4 molecule and what are the steps to be taken care of before we draw the orbital overlapping diagram of methane molecule. And today we will discuss about the applications of hybridization, or what is the state of hybridization of. We were discussing about various type of hybridization. One is sp. Sp will have two orbitals, one s orbital and one p orbital, together sp orbital. So two hybrid orbital, sp2, sp3, sp3d and sp3d2. And here today we take few examples: NH3, H2O, BF3, C2H4 and C2H2 and C2H6. And we will analyze what is the hybridization. How do we find out the state of hybridization for this? I have mentioned in the previous class. So what you need to do is, there is a simple method. So you need to draw the unit structure. So suppose if you take NH3, we know that NH3 is having one lone pair and three bond pair. If you take H2O, H2O is having two lone pair and two bond pair. BF3 is having three bond pair. And C2H4, if you take C2H4, there is a single bond between two carbon atoms. Then each carbon atom will be attached to two hydrogen atoms. C2H2 is having a triple bond between two carbon atoms, and each carbon will be attached to one hydrogen atom. There is a double bond between two carbon atoms, and there is a single bond between two carbon atoms for C2H6, and three hydrogen atoms will be connected to carbon atoms. So here there is a double bond C2H4. That's all. So this is what the simple Lewis structure. So how to predict? So what you need to do, you need to count how many pairs of electrons around the single atom. If you take here, there are three bond pair and one non pair. So four. Totally 4. So 4 hybrid orbitals are required. So sp3 hybridization. So if you take here 2 lone pair, 2 bond pair, again you repeat this 4 pair, 4. Totally 4 pairs of electron sp3. So if you take here, only 3 are there. So it is sp2. If you take here, so this carbon atom and this carbon atom, 2 carbon atoms are here. So if you take this carbon atom, there is a double bond, but we will be counting it as single bond. Because double bond and triple bond will be counted as single super pair. So here only 1, 2, 3. So 3 means sp2. So if you take this carbon atom, 3 means sp2. If you take this carbon atom, there is only 2 bond pairs, because this will be counted, triple bond will be counted as single bond. So 1 plus 1, 2, sp3. Here also sp2. If you take this carbon atom, sp3. Take this carbon atom, 4 bond pair, sp3. This is how we predict. This is a simple way to predict the state of hybridization. Now let us look at how do we draw the orbital overlapping diagram. So if you recall, for CH4 it was like this, sp3 hybridization. So when you answer to the question, when it comes for examination, you have to start with nitrogen. So it is having atomic number nitrogen, atomic number 7. Then if you draw the structure of NH3, it has 3 bond pair and 1 lone pair. Bond angle is somewhere about 107 degree. 3 equivalent bonds and trigonal pyramid. That's what the geometry, trigonal pyramid. So what you need to do is, all these things should be satisfied by the orbital overlapping diagram. So first initially you have to write down the electronic configuration. 1s2, 2s2, 2p3, and here for hydrogen it is So there is a question, why do we require, because if you draw the 2s2, this is how the electronic configuration of nitrogen. 3 orbitals are there having an unpaired electron. Then why should we go for the hybridization? There is a question. So we require to go for hybridization because if you take p orbital will be mutually perpendicular to each other. What is the monadic negativity? So if you take this simple p orbital, unhybridized p orbital, and go for overlapping with the hydrogen, bond angle cannot be 107. It will be negative. So in order to sort out this problem only, we go for sp3 hybridization. From where we go to know that it is sp3 hybridization? Before I have told you how to predict the hybridization. So it is sp3 hybridization. All this will go for hybridization. So sp3 comes like this. Of course, like this. And one of the sp3 hybrid orbital will be having a lone pair of electron. This is lone pair, and 3 will have unpaired electron. This will go for hybridization with 1s orbital of hydrogen, 1s orbital of hydrogen. This is how it comes. So this is the overlapping diagram for NH3. If you take H2O, the next molecule, H2O. So initially, when you draw for H2O, you have to start with oxygen. Atomic number is 8. When you write down the electronic configuration, 1s2, 2s2, 2p4. And when you write down the electronic configuration box diagram, it is going to come like this. So there are 2 unpaired electrons and there are 2 orbitals having unpaired electron. So again, there is a question. If you draw the fluid structure of oxygen, it comes like this. The geometry of oxygen is bend and the bond angle is 104 degree to 28 minute or 1.5 degree. Here, if you take this 2 unhybridized orbital and go for overlapping with the hydrogen, you can definitely form a bond. Both of them will be equal. But there is an issue, that is the bond angle will be 90 degree as we have seen before. So you need to go for hybridization in order to explain this bond angle. So the hybridization is again, as you predicted before, it is sp3. Then if you draw the orbital overlapping diagram, it's like how we have drawn for NH3. So here 2 orbital will be having long ways of electron. You can choose any one, and these 2 will go for overlapping with the hydrogen. So these are bonding orbitals, like not bonding orbital. These 2 orbitals are overlapped with the 1s orbital of hydrogen. And of course, I mentioned when I was talking about the NH3, here you can understand these 2 pairs of electrons are a lone pair of electron, and this repulsion is greater than lone pair. This is lone pair repulsion, and this is lone pair repulsion, and this is bond pair repulsion. Of course, bond pair repulsion is weaker than bond pair, and that is weaker than lone pair repulsion. So what happens? These 2 bonds will come closer. That's why the bond angle is deviated from 109 degree to 104 degree. Please keep in mind. Now let's go for C2H4. So for C2H4, please understand there are 2 hydrogen atoms. It comes like this. So as we predicted before, the hybridization, there are 3. So sp2, there are 3 again sp2. So sp2 means each carbon will have sp2 hybridization. So you have to draw sp2 hybridization will have 3 orbitals, just like in BSEPR theory. When 3 pairs of electrons are there, the geometry is trigonal planar. So for sp2, we will try for C2H4. So for C2H4, double bond C H H H. We know that this carbon is bound for sp2 hybridization. This carbon is bound for sp2 hybridization because there are 3 places electrons around the central atom. So in order to start with, we have to draw the atomic number. Atomic number for carbon is 6, and the electronic configuration 1s2, 2s2, 2p2. And as we have drawn in the previous class, here each carbon atom 1, 2, 2 double bond means 2 bonds are there in the double bond. So 2, 3, 4. Carbon balancing is 4. So we have to prove that. So as we have drawn in the previous class, energy. So this is ground state. This is excited state, and to take 2s2 ground state, 2p2 according to Roffa and Soule maximum multiplicity. And here in the excited state, one of the electron will get excited from s to p. So you will have 4 orbitals having unpaired electron. So what will happen? We have already predicted the hybridization is sp2. So 2p orbital plus 1 s orbital, altogether sp2 hybridization. So sp2 hybridization, just like what we have shown in BF3. So BF3 shape is trigonal planar when it is sp2 hybridization. Just like in BSEPR theory, if these many pairs of electrons are there, what is the shape of the molecule? The same way, if so many hybrid orbitals are there, that is the shape of the hybrid orbital. So if it is 2 linear, if it is 3 trigonal planar, if it is 4 tetrahedral, if it is 5 trigonal bipyramid, if it is 6 octahedral. That's how the shape, just like in what is there in the BSEPR theory. So here it is sp2 trigonal planar. Each carbon will have 3 sp2 hybrid orbitals, and so there is a CC bond. So one of the hybrid orbital of one carbon will overlap with the hybrid orbital of other carbon. If you see that the size is not uniform, excuse me. So here 2 carbon atom, each one is sp2, and one sp2 hybrid orbital of this carbon will overlap with the sp2 hybrid orbital of this carbon. So there is a sigma bond already formed, and please understand there is a p orbital which is unhybridized, sp2. If you take one carbon, there are p orbitals having an unpaired electron, and there is one p orbital which is unhybridized. So you need to show that. So it comes like this. So you can just shade off that dB. Understandable? Here. So these are unhybridized p orbitals. So please understand, this 3 hybrid orbitals are there in the same plane. This 3 in the same plane. So all the hybrid orbitals are there in the same plane, and this p orbital, one lobe will be, if it is horizontal, one lobe will be upper side, the other lobe will be downside. Now I have drawn like this. So one lobe will be directing towards me, and one lobe will be directing away from me. It is inside the core. So that's how the geometry will be. Please imagine. So these 2 orbitals will overlap in order to form a pi bond. Please understand that pi bond will be formed only by overlapping of pure p orbitals. That's what happened over here. So there is a sigma bond and there is a pi bond. This is how you need to draw the orbital overlapping diagram for ethene molecule. We also call it as ethylene molecule. Now, if you go for C2H2, initially you have to draw the simple diagram of C2H2. This is that. So there are 2 bond pairs. hybridization is sp. For this carbon also sp. So you need to draw the electronic configuration. One is 2s to 2p2, atomic number 6. So first, if you look at this 3 plus 1, 4, that's tetravalent. Carbon is tetravalent. You need to prove the tetravalency. So for that you need to go for excitation. So this is tetravalent. And here there is a difference. What is the difference? Is here the hybridization is sp. When the hybridization is sp, please understand they will only go for sp hybridization. Sp. There are 2 p orbitals which is not involved in hybridization. So sp hybridization. Sp comes like this. This is one carbon atom. Other carbon atom comes like this. This is one carbon atom, another carbon atom. sp hybridization. And here sp hybrid orbital of one carbon is overlapping with sp hybrid orbital of the other carbon atom. So there is a sigma 1 in between. There are 2 p orbital which is unhybridized, which is not involved in hybridization. So please understand there is 2 pi bond. So 2 pi bond means each carbon must have 2 p orbital. So 1 p orbital will be drawn tilted to right side, and 1 p orbital will be drawn tilted to left side. Now, when you overlap, this is 1 p orbital, this is 1 p orbital. These two will overlap because those two are like this. 1 p orbital, the other p orbital. They do overlap. Then there are 2 p orbital for one carbon atom, 1 p orbital plates, and another one like this. These two will overlap. So like this and like this. Okay. So hope you are understanding. If you want, you can just shade it out. This is 1 p orbital, which is to take it as horizontal. Another p orbital. This is another p orbital. So these two will overlap. These two will overlap. So there are 2 pi bonds and 1 sigma. That's how we draw the orbital overlapping diagram for ethine or acetylene. That's how it is called. So please see. So before I have drawn ethylene molecule, this is what the model of ethylene molecule. It comes like this. So you could see this is 2 p orbitals overlap. Once they overlap, what will happen? They will spread out to this direction. So it's above the plane and this is below the plane. This is not like the book says that it is egg-like structure. So one will be on the upper side and one will be there on the bottom side. Whereas if you take acetylene, it will not be like this. There will be only one. And acetylene will be shown like this. So you are seeing in a different way. What is happening is there will be one egg-like structure upper side because 2 p orbital will be like this. These two will overlap. There will be one egg-like.